So in this question, we've been given a data set and we've been asked to find various statistics for this data set. The first thing that we're asked to do is to determine the value of the median and the quartiles. So in a list of data, we need to locate the position of the median. We need to locate the position of the quartiles. So a sample size of 13. We know if we want to locate the median, we're going to do n plus 1 divided by 2. So the location of the median is going to be 14 divided by 2. It's going to be the 7th piece of data. 7th piece of data, right in the middle, it's the number 82. For the lower quartile, I'll just do this above, so I've got my numbers in order. 13 plus 1 divided by 4. It's the 3.5th piece of data. That means I'm looking in between the 3rd and the 4th piece of data. Since they're both 79s, that means the lower quartile is 79. For the upper quartile, it's going to be 13 plus 1 over 4 times 3. It's the 10.5th piece of data. It's in between the 10th and the 11th, so it's going to be 88.5. Okay, so I found my quartiles and the median. Part B asked me to calculate the mean and the standard deviation. Now, I've said this so many times, this really just needs to go into your calculator. We shouldn't be using the GCSE technique. Just put these numbers into your calculator, and the calculator is going to give you the sum of x, it's going to give you the n value, it even gives you the answer x bar straight away. These values do need to go into the formula, so sum of x over n, and I always like to write this down. So just good practice, making sure that you're memorizing the formula and plug in the numbers from your calculator. 1096 over 13 equals 84.31. We'll do the same thing for the standard deviation. Make sure you know the formula, sum of x squared over n minus the sum of x over n squared. And all of these values are on that calculator summary screen. We'll just substitute them in. 92,814 over 13, and we'll subtract our mean squared. Okay, that gives us a standard deviation of 5.635. Part C asks us to determine if there are any outliers. So I'm going to go ahead and calculate the outlier boundaries, and then I'm going to check the smallest and the largest value, and just to see whether or not they're inside or outside the boundaries. Interquartile range is Q3 minus Q1. So the interquartile range in this case is 6.5. I know I can calculate the outlier boundaries by using the formulas Q1 minus 1.5 IQR and Q3 plus 1.5 IQR. So the first outlier boundary gets us a value of 69.25. This is smaller than my smallest value. So my smallest value, 78, is actually valid. This shows up a little bit better on a box plot. So we'll wait to see the outlier boundary represented on the box plot. The upper boundary is going to come from Q3 plus 1.5 IQR, and that gets us 98.25. Once again, my largest value is within the outlier boundary, so there are no outliers. All of my data is within these two numbers, is within these two boundaries. I have no outliers in my data. Now, part D of the question, this is where I'm asked to draw my box plot. So I'm going to use all of the quartiles and the minimum and the maximum and the outlier boundaries to help me produce this box plot. So I'll start with a sensible number line. So 70, 75, 80, 85, and so on, just to make sure my whole box plot can fit on. I'll start with the internal box, so the quartiles and the median. For my median, I had 82. For the lower quartile, I had 79. And for the upper quartile, 88.5. Before I do the minimum and the maximum, I'm just going to indicate the outlier boundaries. So here's my 98.25 and here's my 69.25. So anything outside of those would have been an outlier. But my minimum value, 78, and my maximum value, 97, are both within the boundaries. Okay, just for completeness, I do want to make sure we've thought about the other way that we could have found the outlier boundaries. So yes, this is the most popular way, to have Q1 minus 1.5 IQR and Q3 plus 1.5 IQR as the boundaries. But let's not forget we have an alternate way. This is when we use X bar plus or minus 2 sigma. Now usually previous question parts will dictate which ones we use. If we'd calculated quartiles, we'll use that version of the formula. If we'd calculated the mean and the standard deviation, we'll use that version of the formula. I would never recommend you doing any extra work to use one version of the formula over the other. In this question, we'd done both. We'd found quartiles and we'd found the mean and the standard deviation. So it does make sense that we could have just made a personal choice over which way we decided on the boundaries. Now, this question in particular, something interesting happens when we use this alternate version. So let's see what happens. So X bar minus 2 standard deviations gives us 73.04, and X bar plus 2 standard deviations gives us 95.58. What does this mean for our outliers? We know that the maximum value is 97, and now our upper outlier boundary is smaller than 97. That means 97 is now an outlier. So if we'd chosen to define our outlier boundaries this way, we would have produced a different box plot. Let's have a look at the box plot we would have produced. So the internal part is going to be the same. Here are the new outlier boundaries. Smallest value is in the same place. The maximum value, 97, is now an outlier. So we're going to star that. We're going to use the star to indicate that it was an outlier. And we're going to move our maximum top whisker. We're going to move the top whisker to the next biggest value. And that's 92. So now my top whisker goes to 92, and this would have been the box plot that was produced. So for part C and D of this question, we could have gone 2 different routes, both of which are correct, just depending on the definition of outliers that you chose, just depending on the formula for finding outlier boundaries that you chose. In an exam, both of these would get 4 marks.